Hello, good afternoon. My name is Ling. I'm a postdoc researcher at the South Yorkshire Study Centre and also the University of Sheffield. So today I'd like to share a piece of our work on mapping storage infrastructure for a circular economy from more of a whole system perspective. Our motivation for promoting the circular economy in the built environment is that based on this conceptual diagram that we can promote like higher use value of this material through these processes. This is important because from the statistics that we see that over 60% of the waste recovered in the UK waste stream are associated with construction, demolition, and excavation activities. So also a majority of these recovered waste, they are either downcycled or converted into a product of lower values, such as recycled aggregates, or worse, like they end up in landfill. So we need more reuse. However, a key barrier to implement this in the built environment is that we lack of a storage infrastructure to manage and store out this heavy, bulky construction material before they have a chance to be reused, because there's like matching the supply and demand. So our project aim is to address the key barrier on storing material for future reuse. And here we work with our partners, mostly the major infrastructure providers in the UK, and to ask the question that who has the potential space to be used as a storage hub, and how much space they can provide, and where are this facility. So, and with the data collected, we apply it in our model to run a trial network analysis as a proof of concept work here. So how we process the data? First, we locate the storage hubs available on the map and identify the links between two sites, like how far they are from each other across the national infrastructure system, like the railways and the road networks. And here we have all the ingredients we need to run a trial network analysis as a proof of concept. We're on understanding how we can apply a network analysis method. It's more of like a research method to assess like what's the storage capacity of our existing infrastructure in the UK. And in the network form, when we say a node, it can represent a storage site or a construction site and even a demolition site. Whereas for the edges, it describes the relationship between two nodes, or two sites. So it can be a transport distances, it can be the equivalent carbon dioxide emissions, or it can be flow of material from one to another. And we can also assign attributes to the sites to describe the characteristics. For example, what's the size, what's the volume of the storage available, and also like the type of materials that can be stored in there, whether it's a wet or dry conditions. So with this, we produce that map view of the storage sites available and also the network representation of it. Here's an example of the kind of question we try to answer with our analysis. So say if you have like this X amount of material to be transported from site A to site B, which is the best route to take. So let's consider the distance and also the carbon emissions associated with this movement. On the top graph there, each bar represents the distance between two sites. And then from that, we can see that in general, that travel by road is slightly shorter than the travel by rail. But however, if we look at the bottom graph, which shows us that the equivalent carbon dioxide emissions per kilogram of material transported, that we see that traveling by rail has lower emissions compared to traveling by roads, because it's more efficient given like we are moving in bulks. So things can get even more complicated as we expand the network to consider more complex connection and even like more site locations. So next up, we have some of the results that we measure the storage capacity based on the closeness centrality. It's getting a bit too technical, but in a simple way, it means that the ability of a node to spread information. And in this case, it's the ability of a storage site to kind of circulate and distribute the material it has to other locations. And here we look at 3 different scenarios with different conditions. First is the full network. So it has a full connection regardless of how far distant we can go. And we can see that the nodes that located in near the Midlands has higher centrality, of course, because they have like the geographical advantage. And then we can see that there's the form 3 clusters because they have a higher connectivity in the area. And so what if we limit the distance we can go to minimize the carbon footprint? So say that we assume the furthest distance we can go is about 100 miles or 160 kilometers. We can see that only 29% of the edges remain in there. And then some of the storage sites located up in the north has disconnected from the main clusters and forming a separate cluster of their own. And then we can even assume that the shorter distance that we furthest we can go is 50 miles, so it takes about an hour to get there. And only 8% of the connections now left, and then some sites you can see that it goes in isolations because there's no nearby storage within that radius. So this means that we need to set up more storage facility near the area, so then the material recovered have a chance to get reused when there is a demand for it. So in conclusion, that this is a pilot study that we try to shed light on the storage issue, and also we run a trial network analysis to kind of understand what's the impact of spatial distances on material reuse. And we managed to pull data together from some of the major infrastructure providers to explore like what's the storage capacity within our existing infrastructure systems. And in future work that we will continue to look for better data from actually in terms of material use, material supply, and demand, and integrate that in a more of a dynamic model that combines material flow and stocks in the built environment. Also, like advancing a developing of digital tools that will help in widening the applicability of our method. And then lastly, we'll continue to work in collaboration with our industrial partner to achieve that. Thank you.